Okay, so what we're gonna do is we're gonna talk about the next function. But meanwhile, I always ask you piecewise function, and I can't believe some of you guys still don't know how to graph piecewise function because even though I ask you graph a lot, but I'm gonna introduce you one more function because each time there's in pre-calc you're supposed to know all 12, and we already know y equal to x, y equal to x squared, y equal to absolute value x, that's 3, y equal to x cubed, that's 4, y equal to square root x, that's 5, and cube root of x is 6. Today I want to introduce you the reciprocal function. You probably learned this in algebra 2, but I'm gonna go through it with you. But so what we're gonna do is so that's kind of explain to you what you already learned already. So you learned y equal to x. That's an odd function. That's a straight line. So that looks like this. That looks like this. And the y equal to x squared. That looks like u. And it has to be the specific coordinates. And that's why you're supposed to graph the thing. Y equal to absolute value x, it looks like v. You're supposed to know that, and you have to know the translations. So and the y equal to square root x. I feel like I'm missing something. X cubed. So that's a 4 different function already. X cubed. And that looks like something like a waterfall. We can call it waterfall for waterfall. Some people call it a squeaky line. Whatever you want to call it, you should know this 8 coordinates. Okay, so y equal to cube root of x. That kind of looks like this, but sideways. And I don't have enough room, so anyway, I'm going to do a scale of half. So that's going to be 8 right here. -8. So that is the 6 different graph that you should already know. Let's review. Let's review on the thing. I'm gonna write down odd even. This is odd. This is even. This is even. This is neither. And this is odd. And this is odd. And we're going to talk about domain range. So D is equal to -infinity to infinity. Range is going to be -infinity to infinity. This one is going to be domains what? -infinity to infinity. What's range? What is the range for this? 0 to infinity, including 0. And even is y equal to absolute value x. Is what? 0 infinity to infinity. That's a domain. Range is going to be what? 0 to infinity. Good. Neither is going to be, domain is going to be what? Range is going to be what? Do you guys know how to determine domain range? What will be a domain in this one? 0 to infinity. Think about you have scanner. You scanned it. The only time you're gonna scan from left to right, and let me use the different marker. You scan from left to right. The first time you touch the insert is actually start at 0 to infinity, and you scan from here. There's no intersection until you start scanning, which will start at 0 to infinity. So you have to know your domain and range. 0 to infinity. This is all good question to know. Yeah, it is a bracket. And this one's a negative infinity to infinity, negative infinity to infinity, and domain range, domain negative infinity to infinity is also known as our real number. Okay, we're gonna pick like 3 graphs here. We'll talk about M behaviors. What's M behavior to execute? That's what we talked about last time. So you start with the limits, you write down limits. On the bottom, there is an X, and it's approaching. I always start which direction? Left. So negative infinity. And make sure you write down f of x because that's a y. What happened to the y value? The y value is what? If I function approach left, what happened to the y value? Decreases, good. So, but it's going to go to what? Negative infinity. That's how you write it properly. That's an M behavior. So we look at this particular graph. It going left, it's going to go down. If it's going to go down and just stay going down, that is going to be this new representation. Limits x approaching negative infinity is equal to negative infinity. Limits as x approach to what? Positive infinity of f of x is equal to what? Positive infinity. Now, you should learn how to write on all of them here, except square root of x. So this one, I'm going to write it for x squared. Limits as x approach negative infinity of f of x is what? Positive infinity. And limits as x approach to positive infinity of f of x is equal to positive infinity. So they both go up, up. Okay? So that's how you write it appropriate way, how to do the how to do M behavior. Today I'm going to introduce you a new function. It's called y equal to 1 over x. Now this one is really different. Domain and range is completely different. This is called inverse function. No, sorry, reciprocal function. This usually used to model certain situations. So you know how y go to x, you can model like y go to mx plus b. You can use like somebody's getting paid for like $8 an hour, and he have $100 saving. So it'll be y go to ax plus 100. You can model that situation. You can model projectile with the x squared equation. But how can you model y equal to 1 over x? For example, let's say y equal to 200 over x. And you can say, I want to rent a school bus, right? A school bus costs $200 to rent. And depending on how many students it's going to share, right? What happens if you have student 1? You have 1 student. Each student is going to pay how much? 200, right? Does that make sense? Now, if it's linear, 2 students, it's going to pay, it looks like it's linear function right in this point, because 2 students, each student is going to pay $100. But you know it's not true because, oh, right now it's true, sorry. You know it's not linear. Because if 3 students, then if it's linear, you're going to pay what? $0, which doesn't make sense because you should have a common difference. Is that okay? So the third student is going to be big difference. The third student, if it's linear, then they should go to 0. But it's not. How much is it? $66.66. Repeating. Because you just divided by 3. Is that okay? And the fourth student is how much? What is it? $50. Good. And that's, so it's not linear. It's not a straight line. It's like a kind of curve. Okay? And then you can go up to 10 student. How much is, oh, actually 5 student. How much is 5 student? 5 student is equal to 40. And you can go to 10 student is what? 10, no, 20, right? And 20 student is going to be what? 10. And 40 student, 5. But if you realize, it actually never go to 0. Why? Imagine that you can have like a magic school bus. Then you can fit 200 kids on the bus. Then each kid is paid how much? $1. It doesn't matter if this magic school bus can fit 2,000 students. Then each kid's paying 10 cents. But it never go down to 0. Now, never go down to 0. That's very, very important. That you're never gonna go down 0. That's called, in math function, that's called a what? What is it called? Start with the A. Who says what? Yes. Have you guys heard of a term called asymptote before? Yes. Okay. So I'm gonna start with the 1, y equal to 1 over x. And I'm gonna plug in some values. And I'm gonna plug in negative. I'm gonna start with a negative 4. What happens if you plug in negative 4? 1 over what? Negative 4. So I'm gonna start by plugging this value here. Okay, so at negative 4 is 1 over 4. So it's right here. What happened at negative 2? Negative 2 gonna be right here. What happened you plug in 1? 1 over negative 1, so it's right here, right? Are we okay? What happened you plug in half? What happened if you plug in half? It'll be 1 over negative 1 over 2, which is keep change flip. So it'll be negative 2 over 1, so it'll be negative 2. So halfway is going to be negative 2. Is that okay? What happens if you plug in negative 1/4? Negative 4. So it's going to be all the way here. So the graph's going to have something like this. You can even plug in negative 1 over 10. It's just going to give you negative 10. So, so the graph's going to be something like this called asymptote. And the asymptote looks like this. No, so you guys have never seen asymptote before. Have you seen asymptote before? Okay. Now I'm gonna plug in the other side. So I'm not too lazy to plug in the values, but I can. I just be 1 over 10, it's gonna give you 10. 1 over 4 is gonna give me 4. 1 over 2 is gonna be 2. 1 is gonna be 1. 2 is going to give me 1/2. 4 is going to be 1/4. So it's roughly, I'm going to start with 1/4. So it's going to be right here. 1/2. This half 1/4. So pretty much, oops, that's the other way. My fault. It's not that. So it's going to be 1/4 here. 1/2. 2. Half. 1/2. 1/4. So this graph's going to be something like this. So is this kind of stuff is modeled by you sharing a cost of one particular things. So if the bus is cost $200, then how many students? So only in the positive region though. Negative region doesn't make sense, but because I need to use something like that. So it's not linear. I'm trying to say it's not straight line. Now, what is this type of function? Are they even or odd? How do you know it's odd? You plug in negative x, remember? It's 1 over negative x, that's equal to negative 1 over x, which is negative of f of x, which is odd function. Is that okay? Now, let me ask you, what is the domain and range here? This one's kind of tricky. What will be the domain and what will be the range? Hopefully I'm streaming. Yeah, I'm streaming. What will be a domain here? McKenna?
Negative infinity to 0, but 0 is in parentheses, and then parentheses again 0 to infinity.
Nice. Nice job. Nice job. Negative infinity to 0 because it's never equal to 0. But it's going to be a parenthesis here. And then union from 0 to infinity. Am I going too fast? Now I'm gonna range is gonna be what? Well, range is gonna be the same thing because you scan it like a scanner. So you scan it right here, right? You scanned it, and you're not gonna have answer at here because you're not gonna intersect anything at 0. So you kind of leave 0 alone. Parenthesis because you're not including the 0, and you go into 0 to infinity. And you're gonna scan the other way for range, and same thing is gonna happen. You're not gonna get 0, and then you're gonna get all the solutions up there. So that's gonna be negative infinity to 0, union 0 to infinity. Does anybody have any questions here? Yes.
Could you explain the odd function again?
Odd function, anytime you want to know it's odd or even from previous tests, you plug in negative x into the function and see if they are opposite than the original function or the same as original. If they were the same, then it's called even. So for example, if I have f of x equal to 1 over x squared, if I plug in negative x here, it's going to be negative x to the square. And now guess what? That's going to go back to original function, so 1 over x squared, so that's even. But since 1 over x is going to go back to the opposite of the original function, that's going to be odd. And they have two types of symmetry. 1 over x squared is going to have a symmetry of y-axis, and y equal to 1 over x to have symmetry to origin. Origin means like, so for example, pick up like this value. 2 is equal to negative 1/2. If you go to 2, it's going to be positive 1/2. The coordinate, like x and y, if they have opposite value, the output is going to be opposite. Okay? Any other questions? So this is called reciprocal function. Now, what's the nice thing about this function is there is two asymptote. There is an asymptote like this direction. How many of you guys never seen asymptote? Raise your hand if you haven't seen asymptote before. 2? Only 2? Only 2 of you guys? Kaylin and Emerson? Kaylin, which school you come from? Which teacher? How many people have Miss Shell? Safa had Miss Shell, right? Did she show? She did? Oh, you did? Okay. Okay, so there are two asymptotes. If you never know what's asymptote, x equal to 0 is called a vertical asymptote. Y equal to 0 is horizontal asymptote. So there was two type of asymptote. One is a horizontal, one's vertical. By here, the vertical is going to be the green line, and the y equal to 0 is a horizontal line. Yes. Good. I'm glad that you asked that. So, does a line ever touch? That's check out, right? So 1 over x, 1 divided by x. It's like this. Did it touch? Did it touch x-axis? Yes. Okay. I'm gonna ask you to look again. Did it touch x-axis? No. Okay. Well, we're gonna zoom in and see what happened. It's like a magic school bus, right? If you have 2,000 kids in one bus, even the cost $1, 1 divided by 2,000 still equal to something. So it's not able to reach 0. So the way I kind of think about it is like this. Asymptote is like Bennett's relationships. Now he's awake. Like Bennett's relationship. It's never gonna happen. It's gonna get so close, but it's never gonna happen. Sorry, Bennett. You should have helped Jay pull the table out. Huh? Jesus is no longer a target. He's off target for a while. So Jesus gonna get a girlfriend. Jesus has good personality. He's ugly, but he's a good personality.
Okay.
Like he's always smile. Look at him. It doesn't matter how you make fun of him. It's okay. He has a good personality. I think he's charming. Not just me. I don't know. He's not my type, but he could be
No,
charming.
I'm not into guys, man. My bad.
But he's good personality, and I think good personality goes a long way. Like Jesus would have helped her bring out a table. But that next time, you know, that's how you get a girlfriend. Be a gentleman. Okay. And send also Aiden too. Aiden just watch him. Watch her to bring table out. Aiden's worse. Aiden just sit there and laugh.
I have a feeling Brandon was gonna help.
You have a feeling Brandon's gonna help. Aiden just give an opportunity to Brandon. Okay. All right. So this is a 1 over x graph. Now we're gonna learn how to transform this graph as well. So imagine, how would I transform this? What do you think this graph do? They shift what? To the left? Okay. To the right? Okay. Yes, Yan.
It shifts one to the right and up.
Yes. Wow, you're awake. Awesome. Yeah. Imagine you stay awake the whole time. Okay, so this is the 1 over x graph, right? But if you think about it, this is a parenthesis over there. Just like that whatever is parenthesis before. So that is gonna be what? It shift to the right 1 units because inside a parenthesis. Even though I didn't write any parenthesis, now you know there's a parenthesis going over there. And it's gonna go up 2 units. So then your graph is gonna have a asymptote as an anchor point. So remember, this point here is not a point. It's point formed by 2 asymptotes. But this is gonna be an anchor. That part is gonna move accordingly. Does that make sense? Move accordingly. how does it move? Move right 1 unit, up 2 units. So it's gonna be from right here, and it's gonna create 2 asymptotes. Am I going too fast? This is okay. And the graph still in the within the first and third quadrant. It's gonna be like this. You can estimate it. I'm okay with your estimation about this one. You just have to graph the rest of them. And that's it. Yes.
Where did you get the anchor from?
Anchor point is all at 0, 0. It's where 2 asymptotes meet. This point right here, right? Now this point is gonna do the transformation. Because if you transformation, the anchor point is going to create 2 asymptotes. The rest of the graph is going to follow. Is that okay? So always at 0, 0. So we're going to write down this anchor point here. Anchor point, even though this is not math term, so we're going to use anchor point, just use as anchor. Anchor is like the thing that hooked the boat, I think. It's 0, 0, but it's moving according to this transformation. Am I going too fast? Also, one more thing is this. We're going to learn how to write the M behavior here. What happens when limits x approach infinity of f of x here is equal to what? That's excellent. It will actually reach 0. Because it's going to get so close, right? It's going to get close to 1 over 1,000, 1 over 10,000, 1 over 1 million, 1 over 10 billion, 1 over 1 trillion. But the value is going to be infinitesimally small, so it's actually going towards 0. Am I going too fast? Do you guys understand this part? Yes? Yes, Ashton? Think about it. If x go to infinite, right? It'll be 1 over infinite. 1 over infinite is going to be 1 over, just like think about 1 over 1 is 1. 1 over 10 is 0.1. 1 over 100 is 0.01. 1 over 1,000 is 0.0001 or 001. 1 over 10,000 is going to be 0.00001. So the value is going to get smaller, but it's going toward what value? Right? If you have 1 cent, 0.1 cents, 0.001 cents, 0.00 cents, you might as well not have any money because there's no difference.
Infinite number of zeros before the 1.
Exactly.
Infinite, it never ends, which means there is no 1.
Good. And the same thing happened if negative infinity. Just approach 2 different ways. What happens if negative limit x approaching negative infinity? 0. It's also 0. So that's called M behavior. So this is the first time it doesn't go to infinite or negative infinite. It actually goes plateau into 0. And this is also known as a horizontal asymptote because it plateaued to 0. Right? Now, the next one is going to be this one. This one you've never seen before. Except Sam might have seen this before. So 0 from a positive. Whoa, that's the first time you're like, what is 0 from a positive? We are going to pre-cal stuff. Okay, we are not going to stay in algebra forever. We are going to speed about 100 miles per hour. We're going to teach you new things. What happens 0 from the positive? That means 0 from the, actually I'm going to start with 0 from the left. I'm going to start with the 0 from the left. It's negative. So 0 from the left is 0 minus. But that's like look like an exponent, but it's called superscript. Superscript is that means a little bit above, not in the middle. So if you look at here, is 0 from the negative. It looks like exponents, but it's not exponent. That means 0 approach from the left side. Now, if you reach approach from the left side, what happened to the graph? It's going to or what? Negative what? Negative infinity, thank you. It's going to a negative infinity. And therefore, limit x approach 0 from the positive is what? Good. Past infinity. Now, Ian's awake, so he's answering all those questions. Do you guys understand what it meant? If you have a question, better ask now than later. So if Asher have a question, ask. Don't be showing me a question mark in your face but refuse to ask. If you don't understand anything now, you ask. No questions? Yes, Safa?
What's the difference between this and like the limit that we just wrote?
This one is approaching to a value. Last time it's approaching to the end, negative infinity. This is called a one-side limit. It's approaching a specific value from the left and specific value from the right. But the other one's approaching to the end, infinity, or negative infinity. Did that answer your questions? Okay. Is everybody okay? Good. I'm going to ask you to graph combination of piecewise function. Okay? Now, imagine what happened if I were to ask you negative. If I put a negative sign, what would this graph do? If I put a negative sign. Flip which way? Not across the Y. That's very risky. Ashton? Yes, across the anchor point. I love that. I love that. So imagine that if you have that just says y equal to -1 over x minus 1 plus 2. It's still the same transformations, right? It's still same transformation. A lot of you guys on the test refuse to graph. Jada is one of them. Aria is one of them. Katie is one of them. Sarah's getting better. But I'm let you know the name of you guys. It's not because I want to embarrass you. It's I want you don't feel the fear of graphing. Go ahead and graph. You can graph it completely wrong. Just check on the decimals. But you gotta start with the wrong and then go into right. It's just never gonna happen right away. So anyway, it's moving right 1 unit and going up 2 units. So this, it's gonna be like this. But the graph is gonna go this way instead. So it's gonna be 1 and 3rd quadrant. 2 and 4th quadrant. It's gonna be like this. Okay, today you're gonna have piecewise function. You have to graph like this. $90 something. 90, I think. Actually, I'm very impressed about you because you are the only student got all the 3 correct on the bonus questions. Very good job. Yeah. It was pretty bad. $90. Don't know. Yeah, it's good. Now, I think you just need a stand. You don't need a medication. Because you stand, your blood has to flow, and it has to flow. I mean, it's probably still possible to fall asleep, but it's a lot less likely.
I don't fall asleep at night because chronic insomnia.
I know. I'm not mad at you about that. I just want you to do something, which just means I want you to stand up. I want you to finish your test if you don't have time.
I just didn't do the bonus.
Oh, okay. You did finish?
Yeah.
Huh?
I didn't finish it.
Okay, hold on a second. Go ahead and finish it then. I'll write you a pass. Where you going?
Miss Clancy.
Oh, you'll be fine. What?
What'd you-
Ashton, 62.5.
Oh, yay.
Astra, 72.5. Is it bad?
I got a 14.
Huh?
1420.
1420? So you did improve.
720. Better than 630.
You don't need to pay for that damn Hunterton. I'm telling you, you just have to be careful about things. It's not even like hard. You like I told you first day I said 720. And I know that your ability is 720. It just stupid careless, stupid stuff like it's adding up. It's like playing tennis with a bunch of enforced error. Just didn't serve the ball across the net. It's just like you keep on hitting the net. Dude, just hit a pass and then wait for the return because maybe they don't return. That's the problem. What?
Like now they've done, I don't have to worry about the CT.
No.
Oh,
Yeah, that's true too.
I got accepted into college. I don't have to worry about college anymore. I accepted.
If you already got accepted, why are you taking it again?
He's just in a bright future.
Oh.
Wait, let's go, baby. How'd you get from your SAT? What? What'd you get? These are 13. I increased on.
Do you already take?
Okay, well, let's.
No, I don't know. Wait until you take it because that's a. Then you ask me.
I take ACT, not math.
ACT has a math.
ACT.
It has math in there.
You didn't sign me up for that.
No, it has math in the test. It's like math portion of the test.
Yeah.
So like, when are we supposed to take the SAT? Like, am I supposed to sign up for something?
No, it'll be on.
Junior year, you're supposed to take it already. If I were you, I would sign up this year. Because in this year, still paper test. It doesn't mean like it's easier because I think the curve is much harder to reach on digital test because there is so much resource.
What do I sign up for? Talking to you.
No, just
No,
co- yeah.
Where? What did you say?
College- and some family has a voucher too. I don't know how that voucher works. Don't play basketball. I'm gonna hear, dong.
No, you are.
It will hurt my ear, but that's okay. I'll still win.
I've been working, you know, on the jump shots. Oh, when I was doing the Jared the other day, he told me when I did wrong. So I go up and like as I'm at the top after going down, I shoot. He told me I gotta go before. And after doing that, I was like, you know, Ryan. Like it was like one of the I don't know, he was 8 people that I was
Ryan Young.
I had like he doesn't even say it. Yeah, I didn't forget all the studies that
The sound of the shot. Huh?
What costumes did your kid wear?
My oldest son wearing Harry Potter because he doesn't like to dress up. He just want to put on something. Huh? No, I just take out my eye. And then my youngest son dressed as that guy from Demon Slayer, but it's not the main guy, but the guy does lightning.
Oh yeah.
What's that guy's name? Zenitsu?
One thing is a million times.
True.
Practice it a million times.
Yep. Sometimes you have to do that. I buy sausage because one student told me say it's good, but I ended up trying. I didn't like it. But only time I like it is when I'm grading tests, so I get all the shit done. And but nobody else drink it. I heard it's bad for you. I don't know. Does anybody drink Celsius? How do you feel, Laxmi? Did you feel better today?
Wait, how did you get worse? My body feels fine, but my voice.
You know what helps with that?
I think you got the same thing as Elise got. Elise got the same thing like a week ago. She sound like shit. All right, so reiterate. Did you guys went back and redo it? It's a different number. If you got less than 60, then chance you can do it. We did everything? Yes, yes, yes.
Do it. Why?
1 and 7. If you got 1 and 7.
Yeah, maybe.
We didn't finish one.
I forgot that.
I still don't know that.
We didn't even finish one. Finish one.
You know what's sad? Like, I didn't still get on this video just for it not to get a J.
No, it is good. You can see it. It's not the thing. Yeah.
Well, how you doing? What you got?
Means a little weird.
Means the same thing as roll. You need another point. It's long. It's tedious. You're actually speaking with this, so you're actually good.
English SAT.
Yeah.
You know English stuff like for AP.
Oh, hangover?
No, this is how you get to the elite. If you do that, then you get to the elite.
So far, I didn't see anyone be completely 100% right. I can't even give you a 60 points if you don't give it right. So, oh no, the number 7 is not finished. If you're not finished correctly, there's no way I'm gonna give you a point. Single point.
So do we do these questions to get a 60 or do you do the questions to get a 80?
You get a question to get a 60.
Oh, okay.
So I better see you after school because I think none of you guys are finished right. You MCU?
Wait, you forget.
What?
You got another PhD, can you still do it?
You can do it for fun. For funsy.
Let's see that.
That's what you guys called it.
Is there a test on Friday?
There's a test on Friday, yes.
I'm not gonna say it.
All right, so I give you a chance. I'm not meet you in a half, but nobody did it. Everybody went to trick or treat. You did it? Can I see it? Yeah, that was right. I'm gonna keep it. I'll look at it. If you complete it, you can give it to me. What? I'm gonna hold on to this. If you have completed, you can give it to me. Like complete it and knowing it's right. I don't know if Melissa did it right, but she did complete it. I need to see it. All right. If I give you a second chance, you better go back and make sure that you know how to do things right. How to do things. Omar, I cannot talk over you. Nathan, I cannot talk over you. When I'm talking, I need you guys to be quiet.